Hi. Today we're going to go going over square root graphs. Now they are interesting because they work with the same properties of square roots. So, while we're going over square root graphs, it's important to first cover what the properties of square roots are. So we know if we put a perfect square inside a square root, we will get, the square root of that number. But we cannot put a negative number inside a square root. We just can't. Because we know anytime we're squaring a number, like 2 squared, we're always going to get a positive answer. Even if we put -2 and we square it, we're still going to get a positive answer. So there's no way we can have a perfect square that is a negative number. It just doesn't make sense because by squaring it, you're going to eliminate that negative number. So anytime we have a negative value inside a square root, we say that square root doesn't exist. Right? There's no value, no negative value for which we have an actual square root. And that kind of gets into imaginary numbers, but we'll leave that there. Just know that there's no number there's no negative numbers that square roots exist for. Right? What does that mean? Well, that means when we're graphing square roots, so let's say y equals the square root of x, pretty standard square root, we're not going to have anything on this side of the x-axis where we're inputting negative numbers into our graph, because those negative numbers don't exist for the square root. So all activity is going to happen on this side. Also, we know that we're not going to get any negative numbers produced, right? We're just going to get a positive number. So all the activity is going to happen on this quadrant of the graph. And so generally, right, our graph of the square root of x looks a lot like this, right? As you can see, a pretty gentle curve, right? Not a lot of craziness happening. And of course, if we were to graph, let's say this is 2 and this is 4, we get our pattern, and it's a very, very gentle curve. But what happens when we want to graph square root functions that are related to this graph? Well, whenever we're graphing functions, we always want to try to transform them or modify them based on the original graph. So we have this square root graph pictured in our minds. And let's say we're asked to graph, it's a different color, y equals the negative square root of x plus 3 minus 5. And at first, that looks pretty crazy. Looks like a whole lot of stuff. But we're going to keep it simple. So first, we know that there can be no negative numbers that are defined for this, right? There's no possible scenario in which this is negative because it doesn't exist for it, right? So we actually know, hey, if we plug in -3 for this, right, our x will become 0. And that's going to be the lowest possible point on our graph. You might say, why is that? Well, if we plug in any number less than -3, let's say -4, for example, look at -4 plus 3, which is -1. We have a negative number inside a square root. It doesn't exist. So the lowest possible value that this square root can still exist is at x equals -3, right? So at -3, we're going to have this function. So what is it going to be for this function? Well, we're going to have y equals negative square root of 0 minus 5, or just -5. So at -3, all right, we're going to have -5. Okay, looks good so far. We're taking this point and we're moving it down 5, it seems, right? And we notice we've moved this. We starting here and going like this. We move this point down 5, and then over to the left 3. And that's one of the translation rules we can use when we're looking at square root graphs. Anytime we're having a value like this off to the side, whether this could be -5 or +10, that refers to the vertical position of the starting point of the square root graph, right? So in this case, this -5 means, hey, we're taking this point and we're moving it down 5, right? And this +3 means, hey, we're moving it 3 over to the left, right? If this was -3, we'd move it 3 over to the right. Those are translation rules we can use. The last thing we notice, we have this negative sign. And like we would with quadratics or any other functional graph, that negative sign means we're kind of going to be doing some reflecting. But in order to see how that reflecting manifests itself on the graph, we're going to be a little inventive, right? So I'm going to try to get 4. So I'm going to say, well, x equals 1, so that's square root of 4 minus 5, which is -2 minus 5, or -7, right? So for 1, right, -7. Here we notice, oh, well, it's kind of going to be just going like this, on and on and on. We can see that negative sign has kind of caused our direction of the graph to be flipped, right? We've kind of taken this negative sign as a result and sort of flip-flopped it or reflected it across the x-axis. So we're starting to curve up because it was positive, right? Now with that negative sign, it's starting to curve down like this because it's negative. And these rules might seem a bit of a bother, but we'll try to get them up with another practice exercise. So let's say we're asked to graph, this is of course y squared x. We're asked to graph 2 root of x minus 3 plus 2, right? So we're going to use what we learned last time and know that, hey, this plus 2 means we're going to take this point, move it up 2. And hey, this minus 3 means we're going to take this point and move it to the right 3. So our starting point is somewhere round about here. Well, now we have this 2. It's a positive 2, so we know we're not flipping our direction of our graph, of our curve. But what is this 2 going to do? Well, if we think about it like this, right, just so we can do a simple value, we can absorb the effects that this number has being next to the square root, and then we can imagine how that's going to affect our graph, right? So y equals the square root of 2. Y equals 2 times the square root of x. So if I plug in 2, I'm going to, actually 4, where I would normally just have 2 here, I'm actually going to have 2 times 2, or 4. And if I plug in 9, because that's another square, I'm going to have 3 here. But in this case, I'm going to have 2 times 3, or 6. But you can notice that 2 basically means we're doubling all the values on our graph. So that basically means we're going to be increasing twice as fast. So we're going to have a bit steeper of a curve upwards. That's what that 2 does. If this was a 1/2, for example, we'd have the opposite relationship, where we'd be growing half as fast as this graph. So we'd be curving a lot slower. Something like this. That's all the properties of square root graphs we have to worry about. This controls our starting horizontal position, vertical position. This controls our starting horizontal position, and this controls our steepness. And finally, the sign, whether it's positive or negative, determines the overall direction of our graph, either this way or this way. And that sums up square root graphs. I hope you found it helpful, and I hope you have a great day.